Good afternoon, class, and welcome to the introduction of Punnett squares. We're going to start off by explaining what a Punnett square is. So a Punnett square is a diagram that is used to predict an outcome of a particular cross or breeding experiment. So this means if you want to find out the offspring between two parents, that's usually what this is used for. So if you want to predict the offspring between two parents or the probability of what the offspring can be, you're going to use a Punnett square. So I demonstrated what a common Punnett square looks like. So let's say if you're father or mother, it doesn't matter where you put them on the Punnett square, but you're going to have one parent on the top and one down the side. So on the top of your Punnett square, let's say it's the father. He has a big I and a little I. And then the mother also has a big I, little I. We're going to talk about what all of the letters and whether it's dominant or recessive. We're going to talk about all those terms in just a minute, so don't go crazy. We're going to talk it all through. But this is just demonstrating what it actually looks like. So you're going to have one big square cut up into four little squares. So each square is a 25% chance of what your offspring can be. So for the first square, because it's right where the big A and the other big A meet, that's where you're going to bring down. You're going to bring down two big A's. So we're going to talk once again later on what this means, but that means right now it's dominant. So it's 25% chance that your offspring is going to be homozygous dominant. We're going to go through all that in just a minute, but this is what a common Punnett square does look like. So alleles, the definition is one of two or more alternative forms of a gene that are found on the same place on a chromosome. So for example, a big A either from the mother or father side, or a little a from the mother or father side. Alright, so now we're going to talk about what dominant versus recessive means. If you have a dominant allele, this phenotype or genotype is the most common in one parent or in one family even. It's usually represented by a big letter. Actually, it's always represented by a big letter no matter what. The example we're going to be giving today is talking about eye color. So having brown eyes is more common than blue eyes in one particular family. It could be opposite in another family. But in this family, brown eyes is being dominant, so we're going to represent it by big A. Later on, we'll represent it by big B, but for right now, we're just using A. So the recessive allele is the phenotype or genotype that is least common in one parent. So it's going to be represented by the little letter. So having blue eyes is going to be the recessive allele, and it's going to be represented by a little letter because it's not as common in that family. So genotype versus phenotype. Genotype is the words to describe an allele, so it's going to be like the adjectives. So having brown eyes, or blue eyes, or being tall, or being short. It's going to be something like that. And then phenotype is the letters to describe the allele, so it's going to be represented by big A, big B, big T, little t, anything like that. So here's an example for all of you guys to try at home. If it is common for Mr. Potato Head and his family to have brown eyes, what is his genotype considered? Is it dominant or is it recessive? Now let's think about it for a little bit. It's going to be common that his family has brown eyes. So if it's common, what is that? Is that dominant or recessive? Is it going to be represented by a big letter or a little letter? I'll give you a couple more seconds for you to figure it out, and then we're going to move on. Alright. So, like I said, it is common, so that does mean that it's dominant, so it's going to be represented by a big letter. Okay, so now we're going to talk about what heterozygous versus homozygous means. Heterozygous refers to a pair of genes where one is dominant and one is recessive. So for example, you're going to have a big B and a little b. Because they are both different, you're going to have one dominant and one recessive allele put together. This makes it heterozygous. Now if it's homozygous, it refers to a pair of genes where they are either both dominant or both recessive. So you're going to have either big B and big B, or little b, little b. You're not going to have one of both. You're going to have either all dominant or all recessive. That's what it means to be homozygous. Homo means one, or the same. So that's how you can tell. And hetero means different, or two, or more. So that's how you can remember it a little bit. So homozygous means either being all dominant or all recessive. And heterozygous, because it is represented by a big B and a little b, there is a big letter involved, and because there's a big letter involved, whenever, ever there's a big letter involved, it is going to be dominant, no matter what. But it does have a recessive gene that one day it can pass on to their offspring. So somewhere down the line, the family can come up with the recessive gene, if you want. So somewhere down the line, if, let's say, big B, little b, so they're brown eyes, but they carry the recessive allele for blue eyes, but their mate is someone with all blue eyes, so she has both recessive alleles. There's a good chance that because one person has, even though they have a dominant allele represented, they still have a recessive allele mating with somebody who has both recessive alleles, it's a good chance that their baby's going to have the recessive allele. So, even though they're heterozygous, they're going to be dominant because a big letter is involved, but they still carry the recessive gene that they can someday pass down to their children. But if you're homozygous, you're all dominant or you're all recessive. Okay, so let's talk more about the letters. Big B, like I said, this is homozygous dominant because it's two big letters, so they're the same, so it's homozygous, and because they're big, it's dominant. And we're going to be talking about brown eyes, so it's homozygous dominant for brown eyes. Now, big B, little b is heterozygous, and we know this because it's not the same. One's big, one's little, and it's dominant, like I already said. If you always have a big letter represented, it's going to be dominant. So because it is dominant, it's heterozygous dominant for brown eyes. Now you have little b, this is homozygous recessive. It's homozygous because it's the same, you have two little b's, but it's recessive because it's a little letter, and it's for blue eyes because that's the recessive gene that we will be talking about. Okay, so how to construct a Punnett square. So I gave you one for an example. So I'm going to make one out on my own paper, and just exactly how it looks like on the board, and I want you all to do the same at home. Okay, so we are going to walk through this together, and we are going to try to figure out the probability of what this father and this mother's genes can be. Well, their offspring, what their offspring has a probability of being. Okay, so the father's genes, we have big B and little b, and then the mother's genes, we have little b, little b. So we know that the father is heterozygous dominant because it is a big B represented, and it's one big B, one little b. And we know the mother is homozygous recessive, so she has blue eyes, and the father has brown eyes. So if you make a Punnett square just like I did on my piece of paper, we're going to start doing a little bit of multiplication. So we're going to take this big B, bring it down to our first box, and match it with this little b. So when we do a big B and a little b in that first box, we're going to bring that big B down, and we're going to bring the little b over. Now let's go to the box directly underneath. It's going to be the same thing, because once again, we're going to bring that big B all the way down, and then we're going to bring the little b over. That goes in that box. Okay? So now we're going to move on to the top box on the other side. Now, the father's genes now is going to be little b, so we're going to bring a little b down. And then the mother's is also little b, so little b. Father, once again, we're going to do last box is little b, and the mother, once again, is little b. Okay. So now, like I said earlier in the lesson, each box is represented by 25%. So, what is our offspring going to be? We're going to do this in percentage. So, we have two boxes that has big B, little b in it, and two boxes that has little b, little b. So, because they are the same, 25 and 25 is 50%. So, there's going to be a 50% chance that the baby is going to be heterozygous dominant. It's going to be heterozygous because there's two boxes, and it's 50% because there's two boxes that carry a big B and a little b. That's why it's heterozygous, and dominant because the big letter is represented. So then on the other side, we're going to have 50% that's little b, and little b, which is homozygous recessive. It's homozygous because it's the same, and it's recessive because it's represented by a little letter. So it's 50% that the child's going to have brown eyes, and it's 50% that the offspring is going to have blue eyes. Okay, now let's move on to the next slide to make sure our Punnett square was correct and that we did draw it correctly. Okay, so if you saw from before, that's exactly what I said and what I just went over. This is just checking our answers, and we were correct. Okay? So congratulations, you now understand how to construct a Punnett square and understand the definitions that come along with creating Punnett squares. I will see you in class tomorrow, and we will be having a fun activity. It's 20 minutes long that will get you more used to creating Punnett squares and what happens when different alleles meet with different other alleles and what the probability of children can be. Alright, so have a great night.